Video is about frequency tables and histograms. And a lot of this you probably already have seen in other math classes, just because there's always kind of like a little bit of statistics in other math classes leading up to statistics. And by other math classes, I'm talking about like high school or even junior high. Like there's always like some tables in there that they talk about. So that's what we're doing today. We will get into like more stuff, different stuff that you haven't seen, maybe more after the first test. This first test is a lot of just vocabulary and just kind of some words that, or some ideas that you're probably already familiar with in a basic way. So for example, you might not know what a frequency table is if I just say that, but then once we do it, you might be like, oh yeah, I've seen these before. And so frequency table, what this is all about, organizing data in order to be able to understand it better. Because as you can see from this list right here, it says 16, this is number one, 16 people were asked how many miles it takes. And there's a list of people, how many miles it takes to commute to work each day. Okay, cool. I mean, it's just a bunch of numbers. Like there's nothing really we can like get from this information. So a frequency is how often the number occurs, and a frequency table is going to be just listing out these numbers. And what we're going to do, even a frequency table itself doesn't tell you a ton, but it's going to lead into histograms, which is at the end of this video, which will get pictures. So it'll be a little easier to make some conclusions. Okay, so the first thing we want to do on this is we want to put everything in, actually, it says to put it in order from least to greatest. It doesn't really matter. If you want to rewrite them in order from least to greatest, we're going to go through all these numbers anyway, so it's not as important as when we get to median to have them in numbers order. But I am going to just kind of see what numbers we see. So I'm not going to write down every single time a number occurs. I'll do that in a minute, but I'm just going to make a table. And I see that 2 is the smallest. And I have a 3. This is going to be a kind of one of those tables that I draw the lines in after I see how big it needs to be. I don't see any 4, so I'm going to have 5, 6, 7, no 8, 9. Looks like there's a 10. Ooh, getting a little smaller. 12, 13, 18. Okay, this is kind of a crunchy table. On the next one, I'll write it where we have a little more space. But we have 2 columns in all of these rows right here. And so the left column, this is just our data. Our data is in the left column, and then our frequency is going to be in the right column. So I'm just going to tally how many of these numbers I see. So for example, I'm just going to start on the beginning. I have a 2, put a tally. I have a 5, 7. So I'm just going to cross these off as I go through. 3, I have another 2. So remember, you know what I'm talking about when I say tally, right? Like you mark them like this, and then when you get to 5, you cross them over like that. So I'm just going to continue to tally up all of these numbers. So see, I left off at this 2. So then I have a 10, an 18, a 5, another 5, 2 more 10s, another 5, 7, 13, kind of squeeze that in there, a 12, a 2, and a 5. And so that's good for a frequency. It's kind of hard to read because it's just like a bunch of tallies. So, and you can't type that into the computer when you're doing your homework. You're not going to be able to type that in. So for the final part, let me kind of extend these lines a little bit. We'll do a last column, which will just, oh my gosh, don't judge my table. This is terrible. We'll put the actual number. So there's 3, 1, there's 4, because I'm just counting the tallies. There's 4 5s. There's 2 7s. There's 3 10s, 1 1, and 1 of those last few. So these 2 columns, the tallies or the numbers, those are 2 different ways to state the frequency. And then the left-hand column is the data. It's kind of a mess. It'll look better on the next one, but now you kind of have an idea of what we're doing, so it'll be a little easier to do. And look, this list has less numbers in it. Okay, so let's try this again. The following data represent the average number of emergency room visits per day in a small city. So look, there's a lot less numbers. I see a 2, a 3, a 4, 7, 8, 9. So that's 6 numbers. So I need to have 6 rows. So I have my data and I have my frequency, and I'll probably do my frequency 2 ways, just like last time. And I need 6 rows. 1, 2, 3, 4, 5, 6. Okay. So I have in my data, I have a 2, a 3, a 4, and then a 7, 8, and 9. And so now I'm going to tally. So it goes 3, 4, 4. So a 3, 4, 4, 8, 7, 2, 3, 8, 3, and then 9, 9. So what I see here is I have 2. No, I don't. Man, I'm looking at the wrong column. I have 1. Oops. 1, 2. I have 3 3s. I have 2 4s, 1 7, 2 8s, and 2 9s. And so this could just tell us some stuff. There's an average number of visits a doctor in a small city. So it looks like 3 is a pretty popular number because that happened 3 times. And 4, like there's a lot happening right here, 3 and 4 in the middle. And then there's a lot happening here around 8 and 9 because those both have spikes at 2. But notice there's a bunch of numbers missing. 5, well, I guess 5 and 6 are missing in the middle. So it kind of seems like 3 and 4 is going to have some spikes, and 8 and 9. But I'm just kind of guessing from this table. So this doesn't give us the complete picture. This table is just going to help us get to the drawing, and the drawing will make it a lot easier to see. Okay, so far I had things that were kind of close together, right? Like this only went from 2 to 9. And even the one above went from 3 to 18, and there wasn't really that many numbers. But this next one, it is written in number order, the ages, and it goes from 10 to 59, and that's the big span of ages. And so another type of frequency table has these bins. So these over here are called bins. And you'll notice they all have the same bin width. And by bin width, I mean, how fat are they? I'm thinking of the picture. The picture is going to say how fat they are. What's the range of numbers in each line, in each bin? And so it's real easy to just say 9. A lot of people think it's 9. It's actually 10 if you count it out, because if you go from 10 to 19, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, there's 10 numbers there. Because of the 0, it kind of messes people up. But here the bin width is 10 for everything. 0 to 9, 10 to 19, 20 to 29. They all have 10 ages in it. So the bin width is just how many ages, is not how many people. The frequency will be how many people. The bin width is the ages. And we want the bin width to be the same. We talked in one of the previous videos about misleading statistics. And if the bin width isn't the same, let me just kind of draw you a quick picture. This isn't the picture of what we're going to be doing. But if I said, here's this thing right here, look how short it is. And then look how tall this is. But do you see how the width of the number, the span of numbers in them is completely different. So we can't compare those two rectangles because one is short and fat and one is tall and skinny. They need to be the same width in order to be comparing them. I'll talk more about that when we get to the pictures at the end of this. Okay, so here for the frequency, it's going to be the same idea. I'm going to do the tallies, but now everyone from 10 to 19 is going to go here. And this is an argument for why you might want to put the numbers in number order, because this is going to go real fast because the numbers are already in number order. So 10 to 19 is all of those people. 1, 2, 3, 4, 5, 6. I don't even have to tally because I have them already next to each other. 20 to 29 is all of those people. 1, 2, 3, 4, 5, 6. 30 to 39, there's nobody. Oh, we skipped 0 to 9. There's no babies in this class. 40 to 49 is just that one person. And then 50 to 59, we have 2 people. And so I guess it kind of It saves time in one area, but it takes time in another. If you have to put them in number order yourself, maybe you just would rather tally. Here, since they were already in number order for me, I didn't have to do any extra work. I got to skip the tally and it went pretty quickly. So there's two ways to do the frequency table. Every number gets its own row, like up here, or we make bins and we have multiple numbers in the bins. Again, if I had every age listed, almost everything would be one. A couple ages repeat, right? 16 repeats, 22 and 29, a couple ages repeat, but this is more effective to have it in the bins because there wasn't a lot of repeating going on. Okay, now a new word is relative frequency. So the relative frequency is just going to be a percent. Let me write it right here. It is either a percent, a decimal, or a proportion, which is just a fraction. Proportion. I'm terrible spelling. Okay, one of those things, it doesn't matter. I think it says round to the nearest hundredth on this particular problem. So that's leading me to believe that this is going to be a decimal problem. Just look at the homework because they all pop up equally. Actually, I think decimal and proportion show up more. So I'm going to do it both ways. It's a lot easier to get the decimal if you start with the proportion. So I'm going to do it both ways on this problem where the decimal is the final answer. Okay, so I'm basically saying I already know. Okay, so here, let me back up. We have the number of hours that 70 college students work per week at their job recorded in this table. So I know 2 of them work 0 to 4 hours. I know 18 of them work 20 to 24 hours. So it it tells you how many people. I already have the frequency, but the relative frequency is out of the total. What decimal or percent of the total work in those categories? So normally we would add this whole column up and see what it equals. However, I don't know if you caught this. As I was reading it, it said they asked 70 college students. So that means there's 70 total. You can add them up if you want to check. I mean, I suppose if it's not 70, I probably just made a typo. 10, 20, yeah, it looks like 70. Okay, 70 students. And so what we're saying for the relative frequency is 2 out of 70, 2 out of the total work 0 to 4 hours. 7 out of 70. So these are the proportions, 11 out of 70. I'm just taking this number and putting it over 70. 17 over 70, 18 over 70, 12 over 70, and 3 over 70. All right, that's step 1. Step 2 is to take your calculator and divide, and it says round to the nearest hundredth. So I'm gonna just do 2 out of 70, and I got 0.0, it says 0.28. So it's 0.03 because 0.028, that 8 is telling the 2 to go up. So it becomes a 3. Don't miss points on this test because you can't round. Like if you can't round, I totally get it. We're going to have practice rounding in the math, on one of the assignments. I can't think of it off the top of my head. If there's not enough practice rounding, ask me for more practice. Meet me in my office hours. We'll practice. I don't want you to lose points on rounding. Like you do all this hard work and then you lose points on rounding. No, no, no. So if you're having a hard time rounding, let me know. We can work on it. All right, 7 out of 70, no rounding here. This is just 1/10. So I'll just put 0.1. That's exactly what my calculator says. Make sure you're doing this, even if you don't have the calculator you want at the moment, that's fine. This is, you could use your cell phone right here. Like it's just division, but make sure you're seeing what I'm seeing. So that way you see how this is rounding. So this is 0.16. Again, it was a little more complicated in my calculator, but the 7 is telling the 5 to go up. So that's where the 6 came from. 17 out of 70, 0.24. 18 out of 70, 0.26. I'm rounding all of these. So try this at home. Tell me if you're having trouble on any of these. Heck, tell me if I made a mistake on any of those. When I make these videos, like there's nobody out there like in real time telling me when I make a mistake like there is in the classroom. So sometimes it happens. All right, 3 out of 70, last one, 0.04. It was 4.2 and it rounded to 4. Okay, now there's some decimals that kind of got dropped here. They all have decimals here. These are all to the nearest hundredth. Technically, if I added these all up, it should equal one whole, because all of those little parts of 70 should add up to 70 out of 70, which is one whole. However, we rounded. So there is a chance that it equals 0.99 or 1.01. It could be like near 1. So whenever we round, it's never going to be perfectly perfect. But in theory, this is the whole group of all of our numbers. So it should equal one whole when we add it up. Okay. Adding on one more word. So we talked about frequency. That's the tallies. We talked about relative frequency, and here you can see it's listed as a decimal. And that is just saying out of these 50, well, let me read the question first. A researcher gathered data on the number of hours children slept each night. Answer the questions using the table below that records the data of 50 randomly selected children. So just as a review from above, I know this 0.04 came from 2 out of the 50 kids slept 0 to 3 hours. And I know this 0.54 came from 27 out of the 50 kids slept 8 to 11 hours. So you can just put those in your calculators. On this one, there's not any rounding because 50 is the nice decimal. I guess I should turn my ringer off because it keeps going. Okay. Cumulative, we're going to use that word through, here and there throughout this class. It just means like everything from here and everything before it. So think about your GPA this semester. Well, we don't have one. It's like a couple weeks into the semester. Think about your GPA last semester versus your cumulative GPA. So that would be the GPA of every semester at that school. So the same, and everything from this, the most recent semester and every semester before. We're not counting future semesters. That would it make sense? I don't know what your grade is in this class for the end of the semester. You don't know what your grade is next semester. That doesn't make sense. But everything that you've already done. So same thing here, cumulative relative frequency. We're going to take the relative frequency of the line we're on and everything before it. So this is the first line. So the cumulative relative frequency is just 0.04. But for this next line, we're going to take the line we're on, the 0.06, and we're going to add, 0.26, and we're going to add the 0.04 to equal, I don't care if you put 3/10 or 30/100ths because it has everything has the 2 decimals. You might want to just keep the 30. But we take the line we're on and everything above it. So here, this 54. Now, in theory, we would add these 3 numbers together. But we already know those 2 are 0.30. So I really just have to do 0.30 plus 0.54. So I take the line above it, and then because the line above it already has everything, and then the line I'm on. So I'm at 0.84. And then, I just keep changing colors right and left. Okay. And then the last one, 0.84 is the line above it. And then the 16, it doesn't really matter what order you add these in, but just like I was saying above, you're going to get 1 at the bottom. You might get very close to 1 because on the one above, we had a lot of rounding. This one, if you do all the division here, you'll see there's no rounding on this problem. So it worked out perfectly to 1. All right. A, we actually did this already. It says complete the table. B, what percent of children sleep more than 8 hours each night? Now, more than is not cumulative. More than is in, it's not really in the future, it's just bigger, but more is going past the numbers we're talking about. Cumulative is going to the smaller numbers. But I can still figure it out. Here, I'm going to highlight this right here. Here are all oopsies, maybe not. Here are all my people that slept more than 8 hours. 8, 9, 10, 11, 12, 13, 14, 15. So here are the frequencies for those two groups of people. So the relative frequency, or the percentage of children that slept those two chunks of times, or anything more than 8 through 15, is going to be the 0.54 and the 0.16, which equals 5.6.7. And as a reminder, if it's been a while since you've done percent, we just go over 2 places and we see that it equals 70%. That's why I kept the 0 there, because it just makes it easier for percent. So just as a practice, it's not asking you to do this, but just as a practice, this would be 16%. This would be 54%, 26%, oops. And then finally, moving it over 2 places is just a 4. So that would be 4%. If you need practice with percent. Okay. Next up, what percent slept 7 hours or less? So I will do that in pink here. So here are my 2 chunks that did 7 hours or less. That would be the 0.04 and the 0.26. However, because it's from the beginning, the 0.04 is included down to the 0.26. That's the same thing as, I don't know if I could highlight my own writing. That's the same thing as the cumulative relative frequency. So whenever it's less, oh, didn't mean to do that. That's okay. We can do the cumulative relative frequency. Whenever it's more, we can't. I think that's a G right there. What's going on? I said last time I'm learning my new pen, and I like this little eraser button on the pen. Okay, anyways, it is 0. Okay, sometimes I like the eraser button. I didn't like it right there. We know that's the decimal, so then it would be 30%. We know that's the decimal because of what I did up here in pink. It's the 0.04 plus the 0.26, which we already did. So anytime it says or less, you can just use your cumulative relative frequency. Anytime it says more, then you'll have to add up those individual lines that they're talking about. Also, pat myself on the back for saying cumulative relative frequency so many times without messing up, because those are just a mouthful right there. Okay, last one, and then we'll draw pictures. So here it says, basically the table's almost all filled out, but it says, first of all, what is the missing cumulative relative frequency? So I see one is missing right here. So we need to fill that in. And so we could just go through the way we would calculate it. The way we would calculate it is we would take the row above it and we would add on the row that we're in. So then the answer would be, well, let me write it out where the problem is. The answer would be 0.53 as a decimal. It does not say what percent, it just says to find the missing value, and all the values on this table are in decimals, so I'm just going to leave it like that. One thing I haven't talked about with this homework, I don't know if you've seen this because there's just been so many vocabulary words, but you're definitely going to see it starting in this section. If you throw in some numbers and you get it wrong, you get an extra chance. But after that, if you miss it twice, then you get a new problem. And what this homework is it's mastery based. So that means the faster you show the computer you know what you're talking about, the less homework you'll have, the less problems you're going to have. But it also means the faster you show the computer you don't know what you're talking about. Like if, sometimes you just like spam the enter button and you're just like, and you just hit it a bunch of times and you get everything wrong. Then the computer's like, whoa, like we need to do like a ton more practice. And you could end up in like this cycle of just like getting it wrong, doing more, getting it wrong, doing more. If that happens to you, stop. Either come to my office hours, schedule an appointment, or just shoot me an email and we could just chat over email. and I'll jump in and I will point out what you're doing wrong to help you like correct on the right track. You can just tell me what section you're on because I can see which ones you missed once you tell me what section you're on. And yeah, like, you know, if you miss a couple, of course you're going to miss a couple. Everyone misses a couple. But if you start missing it and you see your progress bar shrinking, and you're getting really frustrated, first walk away. That's always a good thing. Go do the laundry or like do the dishes or something. But then when you come back, if you're still getting them wrong, it's not, you know, maybe you weren't frustrated. Maybe you're really struggling, and just shoot me an email and we will get through it together. Okay. Anyways, what percentage have 3 or more? Okay. Oh, golly. What did I click? I don't know what this thing is right here. Okay. Well, anyway. Okay. 3 or more is not cumulative. It is the or more part. So we want to do 3 or more, 3, 4, 5. So we're just going to add those 3 numbers together. 0.25, 0.13, 0.09. Throw it in any calculator and we get 0.47, which is 47%. Okay. Last but not least, what percentage have 1 or 2? This also is not cumulative relative frequency because it does not include 0. So 1 or 2 is just those 2 numbers right there. We could do this 11 and 22, that equals 33. You just add it up real quick. You could see this answer is not 33, it's actually 53. So since it doesn't start at 0, the only time you can have cumulative relative frequency is if it starts at 0. So we're going to have 11 and 22. It says what percent? So I will write that as a percent. 33% have 1 or 2 children. Okay, enough with tables. Now, okay, so we're going to have tables, but we're going to make them look like pictures now. So 2.1b is histograms. So a histogram is a graph or a picture that shows you the shape. Histograms are going to be with us for a long time in this class, but we can see this shape right here, and it can show you the center. So we can see, we'll talk more about center coming up, but right here, I think it's in the next video, but examples of center would be like words you've heard before, would be like mean, median, and mode, that kind of stuff. So we could see where the middle of this graph is. We can see the spread. We're going to do these words a lot more in the next section, but we can see the spread of the data here. But also, like right now, I could see the frequency like really easily, because you'll notice that the vertical axis has the frequency on it. And so I can see with more clarity perhaps than before that this is the tallest. And I can see that this one next to it is kind of close. I'm going to guess, looking at this is like 14 or 15, and then this is like 11. Just by, it's kind of hard to tell for certain because this graph is so tiny. Whereas this over here, the 15 to 20 range is like maybe 4. So I can just, 4 to 14, has a space in between it, but it's hard to tell if that's a big space or not a big space, because it kind of depends on what you're talking about. But I can see from this picture that there's a pretty big drop off right there. So it just helps me tell more stuff about the picture. We're going to interpret these later. I'm just kind of just talking about the basics right now. I do want to point out that they are rectangles or boxes that are touching. So it says up here that they need to be adjoining, touching boxes. We don't want spaces in between. The only time there would be a gap is if that number is truly 0, if that number occurs 0 times. Also, where the cutoff is, like 5, well, does that mean if you were 5, you were in the first box or the second box? We'll talk about that when we make our own. Okay, so looking at this first one, so this is a great time to talk about the numbers. A lot of times you'll see the numbers at the bottom be in decimals, and this is why. Because this is talking about the number of students who checked out library books. I think it's actually the number of books that they read. I don't know. Okay, number of books that they checked out. And so you're not going to check out half a book, right? You're going to check out a whole book. But Oh, this is not, yeah, the number of students and how many books they checked out. So how many students checked out one book? I can see it's 11 because it's halfway between 10 and 12. How many students checked out two books? Then that would be 10. 3 books would be 16. 4 books. I'm just doing all of them right now, and then I'll talk about why there's the decimals. 5 books, looks like it has a height of 5, and 6 books has a height of 2. Okay, the reason we do it with the decimals is because if I did it like this, 1, 2, 3, and somebody checked out one book, is one book between 0 and 1, or is one book between 1 and 2? Where does the 1 actually go? But I'm only talking about 1. So I want 1 to be in the middle is my point. So if I go from 1/2 to 1.5, you know 1 book is in this column right here. And if I go from 1.5 to 2.5, then you know 2 books are in that column right there. So there's no question as to which column they fit into if we use the decimals around the numbers. Okay, so I like to label the heights of everything right off the bat because this is, look at all these questions. How many, oops, that's my eraser. Try again. How many, how many, how many? All of these are going to be how many students. I need to know the height of that tower. So since I have all the towers already done, it'll be a lot faster to do the questions. So first, how many students read greater than 4.5, but less than 5.5? Okay, so let's think about that right here. Greater than 4.5, but less than 5.5. That means 5. How many students read 5 books? And we can see that 5 students read 5 books from the picture. So how many read 5 books? 5 students. I could just see it right here on the height that there was 5. How many students checked out more than 2.5? So more than 2.5 would be 3, 4, 5, or 6 books. That's what we're looking for here. More than 2.5 is how many checked out 3, 4, 5, or 6. So I look at my histogram. I see that 3 has 16. 4 has 6, 5 we already said was 5, and 6 had 2 students in it. And so those are the numbers that I'm going to add up to get my total number of students. So 16 plus 6 plus 5 plus 2 equals 29 students. I'm trying to label these. You won't have to label them on the homework because they'll already be labeled, but I'm labeling them because, like the last question, it was 5 books. How many had 5 books? The answer is 5 students. So I didn't want to get mixed up because it all had the number 5 in it. So we're asking about how many books, and the answer is going to be how many students checked out that many books. Okay, how many students checked out at least 4.5? So at least 4.5 is going to be 5 and 6. Because it's saying here's 4.5. Anything 4.5 and more is going to be our answer. And in this case, 4.5 and more would be 5, or it would be 6. So now that we know that it's 5 or 6 books, I don't like how hard it is for me to hit the button to switch to the different colors. All right, I'll get over it. 5 or 6 books, we said 5 students had 5 books, 2 students had 6 books, so that equals 7 students altogether. All right, last but not least, I'm going to look at this picture, but then I'll move it up to write it. We have how many students checked out 3.5 books or less. So going back up to the picture, here's my 3.5. Less would be anything smaller. So we're going to add up those 3 heights, the 10, the 11, the 10, and the 16. So 3.5 books or less that is going to be 3, 2, or 1 book. And 1, 2, or 3, it doesn't matter how you add it up. And then we said that was 10, 11, 10, and 16. 11, 10, and 16 tells us that it is 10, 20, 37 students. Okay, so all of these were how many students. So I was looking at the height of the towers on the histograms. Last one, we are going to make our own histogram. So here we have, good, I gave a space for this one because we're going to need to do a frequency table in order to do a histogram. So they're already in number order. I can see I have 1, 2, 3, 4, 5, 6. So for my data, I'm going to have 6 rows. And for the frequency, I just need to count since they're in number order. So it looks like I have 3 ones. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 twos, 3 threes, 2 4s, a 5, and a 6. So again, like I've said before, we don't want to put 1, 2, 3, 4, 5, 6 on our horizontal, or our x-axis. And then also up here, do you notice it started as 0.5, but this line is 0 from math, right? So it started a little bit in. So this is just like a graph, XY graph. So we want to start with our number line. So I'm going to do the same thing, 0.5, 1.5, 2.5, 3.5. Oops, these are decimals. They're not showing up very well. 4.5, 5.5, and 6.5. All of the widths are the same. They're all, these all have a bin width of 1. And so then let's see, it goes up to 8. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So the first one should go up to 3. The second one goes up to 8, and the rectangles are touching. So since I already have the right side of the first rectangle, that means I'm starting my left side of my second right triangle, or my second rectangle right here. So I just go up to 8. And then the next one is also at 3. And then at 2. So I'm just making sure these are all connected. If they have gaps in them, they are wrong. Sometimes people like to do them on the computer. That is fine, but you will need to, there's a way to adjust it. I think it's called the gap. I'm not 100% because I don't do it on the computer that often. What am I trying to say? There's a project coming up when the first test is, which is like in a few more weeks. Drawing this will be on there. If you have gaps in it because you just drew the gaps, well, write yourself a note right now not to draw gaps. But if you have gaps in it because you're using a computer program, you're still going to lose points because you no gaps no matter how you make it. So if you like to use computer programs to draw graphs, like what I'm talking about is like Excel or Word, you can insert pictures. A lot of people like to do that. That's fine. Still no gaps. So you're going to have to like Google how to get rid of the gaps or whatnot, because I know there's a way. Okay, that's it. That's all I wanted to say about that. If you have any questions, shoot me an email. Otherwise, I guess next up, mean, median, and mode.